Hello everyone, I'm Vibhor Singh, and today we'll be discussing the 15th problem of the CP-31 sheet by TLE Eliminators under the 1300 rated parameter. So as you can see, this is the CP-31 sheet, a 1300 rated problem set has been selected, and we'll be discussing the 15th problem, that is deep down below. Okay, so in a certain video game, the player controls a hero characterized by a single integer value power. The hero will have to beat monsters that are also categorized by a single integer value armor. On the current level, the hero is facing n caves. To pass the level, the hero must enter all the caves in some order, each cave exactly once, and exit every cave safe and sound. When the hero enters cave I, he will have to fight ki monsters in a row. The first monster with armor AI of 1, the second, then a monster with armor AI of 2, so on till armor AI of k of I. So hero can beat a monster if and only if the hero's power is strictly greater than the monster's armor. If the hero can't beat the monster he's fighting, the game ends and the player loses. Note that once the hero enters a cave, he can't exit it before he fights all the monsters in it, strictly in the given order. Each time the hero beats a monster, the hero's power increases by 1. So find the smallest possible power the hero must start the level with to be able to enter all the caves in some order and beat all the monsters. Okay, so let's try to understand the problem with the help of this example over here. That is, so you're given 2 is the number of caves, then for each cave you're given its length. So the first cave is 3, second is 2. That is the number of monsters in the cave. And then for the first cave, you have 10, 15, and 8. And the second, you have 12 and 11. So you have 10, 15, and 8. And then the second one is 12 and 11. So these are the power levels of the monsters in these caves. Now, what does the problem say? First thing is that we can enter the caves in any order. Okay. Then, once we enter the cave, we cannot leave it till we have completely defeated all the monsters in the cave. And the third thing is that we have to defeat the monsters in order. That is, let's say I enter this cave. Then I'll first defeat this monster, only then can I defeat this monster. Or first I'll need to defeat this monster, only then can I fight this monster. Right? So, for this example, we need to find the minimum power to start with in order to be able to defeat all the caves. Also, it is given that once we defeat the monster, the power increases by 1. Okay, so let's try to understand this. See, let's say I'm starting with this cave. And initially I start with 13 power. Why am I starting with 13 power? If I start with 12 power, I will lose to this monster. Why? Because our power should be strictly greater than the power of the monster. Only then can we defeat it. Okay, so let's start with 13. So I'll come to the first monster. I will defeat it since my power is greater than its armor. So my new power becomes 14. Okay, then I'll come to this monster. My current power is 14, which is greater than 11. So my new power will become 15 since I have defeated this. Now after this, I will enter the second cave. So after this, see, we can choose any order. Right now I chose this cave first and then this cave, right? We can do vice versa, but it is more optimal to do it. Why, we'll understand while solving the problem. But over here, it's more optimal to do it in this order. So we have 10, 15 and 8. See, now after defeating all monsters in the first dungeon, see, initially I started with my power as 13, right? Then it became 14 and 15. So after defeating all monsters in this cave, my new power currently is 15 only. Okay, my new power is 15. Now my 15 is greater than 10. So my new power becomes 16. Now 16 is greater than 15. So my new power will become 17 and I can defeat 15 or this monster. And then next 17 is greater than 8. So I can defeat this monster. My final power becomes 18. And I can clear both the dungeons. I can clear the level. I can clear both the caves. Defeat all the monsters in both the caves. So I'll say that 13 is a possible answer. Or it is my current answer. Right? Why? So even to see why it is more optimal to take the second cave first and then the first cave. If I start with 13 for the second cave, for this cave. Okay, or I start with 13 for this first cave. So that is 3, 10, 15 and 8. And I started with power 13 with this cave. First, when I defeat this first monster, my power becomes 14, right? But now 14 is less than 15, so I will lose over here. I will lose the game over here, right? I will lose the game over here. That is why we started with the other cave. And also, we can note that for this cave, for the second cave, minimum requirement was 13 because if we start with 12 or below, we'll lose to the first monster itself. And for the second cave, even for 13 we are losing, so we need a greater starting power. So from here I can get an idea that yes, 13 will be my answer. It is the minimum power that I would be required to start with to be able to defeat this level or to be able to win this level, choosing any order of the caves, or choosing that I'll go to the second cave first and then the first cave. And that is what is the answer for this test case. So this is the test case and the answer is 13. So I hope the problem statement is clear to you. Moving on to the expected time complexity. So we are given that n goes till 10 raised to 5, ki goes till 10 raised to 5, a of ij goes till 10 raised to 9. We are also given that sum of ki over all test cases does not exceed 10 raised to 5. And we have number of test cases 10 raised to 5 as well. Okay. So you are given that n is equal to 10 raised to 5. We can ignore number of test cases since we are given the constraint on sum of k. Now we know that sum of k will always be less than n, right? Why? Because see, n is the number of dungeons, right? N is the number of dungeons. Oh, sorry, number of caves, right? Now in each cave there will be at least one monster. So the sum of overall number of monsters will always be less than or equal to the number of caves. And n is number of caves, k is number of monsters, right? And this is 10 raised to 5. I've written k, so this is 10 raised to 5. So I can just form my time complexity in terms of k, that is anything of the sort of order of k or order of k log k should be fine, but anything of the order of k square or greater, or even order of a of I, where our a of ij goes till 10 raised to 9. So a of I comma j goes till 10 raised to 9. So anything of this format will give us, this is till 10 raised to 10. This will go till 10 raised to 10. This will go till 10 raised to 9. So anything of this format will give us TLE. So I hope the expected time complexity part is clear. Now let's try to understand the solution to the problem. Okay. So now we are given a number of caves and we can enter the caves in any order, right? So very intuitively, the first thing that I can think of is we should try to find that what will be the minimum power to defeat a single cave. That is, let's just clear out that there are so many caves. Let's just say there's one cave. Okay, so there's one cave. Let's say it has 5 monsters, and the values of armor are 1, 2, 3, 4, and 5. Okay, these are the values of the armors of the monsters. Okay, now to defeat this cave, I want to find the minimum power to start with, right? So let's say my initial power is x, right? So x will first, with the power x, I will fight the first monster. If I defeat it, my new power becomes x plus 1, right? So let's just write it below. See, first monster, if I defeat it, I'll fight it at power x. If I defeat it, my new power is x plus 1. So the second monster, I'll fight with the power x plus 1. Then the third monster I'll fight with the power x plus 2, fourth with the power x plus 3, and fifth with the power x plus 4, right? Now we have, for the starting power, we have what power we will fight each monster with, right? So now let's see whatever the power for whatever the armor of this first monster is, that is, let's say it's a of I. Okay, so let's say it's a of 1. So I have just given values 1, 2, 3, 4, 5, but considering we don't have values right now, let's just try to form an equation that a of 1, whatever the value is, in our case we have 1. So we have a of 1 should be less than x, or our x that we choose should be greater than a of 1, right? Now similarly, a of 2 should be less than x plus 2, x plus 1, right? And this is 1 based indexing. So a of 1 should be greater than should be less than x should be greater than a of 1, x plus 1 should be greater than a of 2. Similarly, we have x plus 2 should be greater than a of 3. We have x plus 3 should be greater than a of 4. And this is all 1 based indexing, right? And x plus 4 should be greater than a of 5. So I have all these conditions, right? I have all these conditions, and my x should be greater than whatever the values, right? So let's try to form an equation for x itself. That is, instead of taking, I'll take plus 1 over here, I'll take plus 2 over here, I'll take minus plus 2, 3 over here, they'll just become minus signs. I'll get one single equation. X should be greater than some set of values that are A1, A2 plus 1, A3 plus 2, so on and so forth, right? And we'll have An plus n minus 1, right? So this is what we have as an equation, that our x should be greater than each of these values individually, right? Or we can say that x should be whatever the maximum of these values is, that value plus 1. Okay, whatever the maximum of all these values is, that value plus 1 can be our x. Why? Because whatever the maximum values, see, let's say this is, if we take our entire example over here, this is not plus sign over here, this is a minus sign over here. So we'll have a2 minus 1, a3 minus 2, and an minus n minus 1. Okay, so whatever the maximum of all these values is, x should be greater than that, right? If it is greater than the maximum of all the values, it will be greater than any other value, right? And what is this? Since we want to minimize x and ensure it is greater than the maximum of these values, we will just take x is equal to 1 plus max of a1, a2 minus 1, a3 minus 2, so on and so forth, right? So for each dungeon, I got whatever minimum value x of power, or whatever minimum value of power that I require, x, that will be x, whatever minimum value of power I require in order to defeat that cave, right? For each cave, I've gotten this value. So I hope this part is clear. So we have solved for each cave that for each cave I will get some certain value, and it will be an array, right? It will be an array of the form x1, x2, so on and so forth, xn, right? I'll get n values for each value representing the minimum power required to clear the cave, right? Now there's still another part to the question, that there are multiple caves, right? So how do I solve for that? Now, once I have the minimum power for each cave, what will be the optimal order in which I should solve, or what is the optimal order in which we should enter the caves? See, if one cave requires 15 power to be cleared, another cave requires 12 power to be cleared, another cave requires 10 power to be cleared. Okay. So minimum power for cave 1 is 15, minimum for cave 2 is 12, minimum for cave 3 is 10. And you know, by entering the cave, you will get some increase in power as well, right? When you enter the cave, after you defeat all the monsters, you will get some increase in power. So it will always be optimal to select the lowest value cave first, right? Or the lowest power requirement cave first, right? It's very logical. Because let's say over here there were 3 monsters in this cave. So there were 3 monsters in this cave. I started with 10. I'll defeat the 3 monsters. My new value will become 13. Right? So if I take my initial starting value, it was 10. Now it became 13, 10 plus 3. So it became 13 here, which is greater than 12. So I'll be able to defeat this dungeon as well. And let's say it has 2 monsters in it. So once I defeat this dungeon, I'll have my new power as 15. Right? So this is, I'm just writing the values of what is our power while entering the dungeon. And again, now 15 is greater than or equal to 15, which is what we have calculated, the minimum power. So even with starting with 10, I can reach the end and I can say that I have defeated all the dungeons, right? So this part I'll come into greater detail, but first it's important to understand that once we have the values of minimum powers for each dungeon, it is always optimal for us to go enter the dungeon with the smallest power requirement first. Okay, so I hope this much is clear. So now let's just work with the lengths and power requirements of the dungeons. So let's say first dungeon required 10 power minimum power to be cleared, and it had 4 monsters. Okay, so this is the first dungeon. Now the second dungeon has 15 power requirement and it had 2 monsters. And the third dungeon, let's say, has 17 power requirement and it has 5 monsters. Okay, so now I know I should enter this first dungeon, that is with power 10. I should enter this first, then the dungeon with minimum power requirement is 15, and then the dungeon with minimum power requirement is 17. Right? Now, Now, when I'm entering the dungeons in this order, let's say I'm starting with a value. Let's call it y. Let's call it y. Okay. So for the first dungeon, I will need to enter it at power y, right? See, I started with a power y. So the first dungeon I'll enter with y. It can be 10, it can be 11, it can be 20, whatever we choose, right? And this is what we want to find. Y is what we want to find. Now the second dungeon we'll enter with the power of y plus 4, right? Because there were four monsters in the first dungeon. So the second dungeon I'll enter with power y plus 4. Similarly, once I'm able to clear this dungeon, I my new power will become y plus 6. I'll defeat two more monsters. So my power will become y plus 6 while entering the third dungeon. Right? And now I know my first y should be greater than equal to 10. My y plus 4 should be greater than equal to 15. And my y plus 6 should be greater than equal to 17. So I have a very similar condition as before, similar thing as before that. I'll just form a single inequality for y. And what will I say? See, y should be greater than or equal to min power requirement of a current dungeon minus sum of monsters in previous dungeons. Or not dungeons, rather in previous caves. We have caves here. So y should be greater than equal to the minimum power required for a current cave minus the sum of monsters we have defeated till now in all the previous caves. And this is how we'll find our final solution y, or final answer y, with which we can start and defeat or win our current level. Right? So I hope the entire solution workflow of the solution is clear. See what we are doing first. First we are understanding that how can I defeat one particular cave at a time. So for one particular cave, the minimum requirement is x, and for x I got this equation that x should be 1 plus maximum of a1 comma a2 minus 1 comma a3 minus 2, so on and so forth. Why? Because x should be a minimum value that is greater than all these values, that is the requirement to defeat the monsters, right? So that is how I'm getting for each cave. I'm calculating the minimum power requirement for that cave. Then we establish that for each cave it is better, or once we have the power requirements, it is better to take the minimum power requirement cave first, or enter the minimum power requirement cave first. Then once we have the order in which we have to enter the caves, it's a very simple problem, repeated problem of what we did earlier, where we had to defeat monsters in an order. That first we'll enter the first cave, then in the new second cave we'll have the initial power plus the number of monsters we defeated in the first cave, and so on and so forth. That is why whatever a minimum power requirement would be, it will be minimum power required for our current case. So it will be like max over all values. So max over all the values, this entire thing. So it would be maximum over all of this equation for each of the cave. And what is the equation? Minimum power requirement of the cave minus sum of monsters defeated in previous caves. So I hope the overall workflow is clear. Let's move on to the code of the problem. So initially we took number of test cases as input, and then we took n as input. And I created a vector of pair of int comma int. Now what will this store? This will store minimum power requirement and the length, because these are the two values that we require, right? We will require at the end minimum power requirement of the cave and the length of the cave, right? So that is why we created a pair of int comma int for this purpose. The first will represent the minimum power requirement, and second will represent the length of the cave. And minimum power requirement should be the first value, because we want to sort over it, right? So unless you want to put a custom sorting function, our normal sort will work if we put it as the first value. And then I created a vector for taking the current input, although it's not really required to create a vector. Then m is the length of our current cave, or the number of monsters in the cave. Then I took the value of the monster and I have pushed back what is the requirement to beat this monster, right? So see, what were we calculating first? The minimum power requirement, and that is 1 plus max of all these values, right? So what I have done here, in the vector only I have pushed back the power requirement for that particular monster, that is x minus j plus 1. Since we have 0 based indexing, see over here I had 1 based indexing, so I had a of 1, a of 2 minus 1. But if we have 0 based indexing, it would be a of 0, a of 1 minus 1, a of 2 minus 2, so on and so forth. That is why x minus j, and then the plus 1 because we need one more value, that is 1 plus, we need strictly greater, that's why 1 plus whatever the value is. And then I've sorted it, and then in the vector I've pushed back. So once I sorted, the last value would be the greatest value, right? I've sorted it. Once I've sorted these values, the last would be the greatest, and that is what I have to push. That is the minimum power requirement for our current dungeon. So in our vector A, I'm pushing back the minimum power requirement, comma, the length or the number of monsters in the current cave. Then I've sorted the vector A, and then I initialize my answer as A of first, that is the minimum power requirement to enter to clear the first cave itself. So A of 0 first, and what is increase? Increase towards the power, increase in power or the number of monsters we have defeated till now, right? So since I started answer with A of 0 dot first, we will be able to defeat the first cave entirely. So after defeating the first cave, our increase in power would be A of 0 dot second, or the number of monsters in the first cave, right? And then starting I from 1, since I've already dealt with A of 0, starting I from 1, I less than n, I plus plus, we are doing answer is max of answer and A of I dot first minus increase, right? That is the minimum power requirement of the current cave minus the amount of power we have increased till now, right? So we can just rename increase to number of monsters defeated till now, right? So this stores the number of monsters defeated till now. So answer would be maximum of answer, comma, the minimum power, current minimum power requirement minus number of monsters defeated till now. And once we have defeated this current cave, a number of monsters defeated till now will be increased by A of I dot second, or the number of monsters in the current cave. And finally, we are printing the answer. So that's it for the solution discussion. Yeah. So that's it for the solution discussion. Now let's discuss the time complexity of the solution. So for this entire loop, we have outer loop running in order of n and inner loop running in order of sum of k, that is given in our question, right? That is the k is the number of monsters, right? So this overall entire looping will run. In the order of number of monsters, right? So we can just write it. This is order of sum of k, right? We can just directly write the overall order of this entire loop will be sum of k, or we can just write it as k itself, because we are given a constraint on sum of k to be 10 raised to 5, right? Then the number of values will be in A would be n, right? That is A stores for each cave. It stores the value for each cave. So number of values would be n. So sorting will run in order of n log n, and this loop will again run in order of n, since we are not doing any complex operations inside the loop. So overall time complexity will just become n log n plus k, right? So we have time complexity is equal to order of n log n plus k. So this is the overall time complexity of our solution, and the space complexity of our solution. So we have taken this. So we are we are creating vectors for the number of monsters. So that overall length of this vector v can go maximum till k. That is the number of monsters, and our overall length for vector a can go till n. Right. So overall space complexity can be written as order of n plus k. But as we know n plus k, we can also write it as k itself, since k would be, since we established earlier that k would always be less than equal to, or k will always be greater than equal to n. But we can just write it as order of n plus k for now. So that's it for the space and time complexity discussion. I hope you were able to understand the solution. Thank you.